Hey guys, so I know it's tough. This is how we feel at this moment, like presented to a crowd 2 minutes after complete the lunch, so it's challenging. So if you drop for some time, so you feel dizzy or sleepy, it's okay. We're going to finish it anyway. So guys, thank you very much. What is the session about? KNative, we heard about it. I'm advocating about it at least for the 2 years now. But to be frank, it's still not well adapted. But at this 30 minutes, what we'd like to do, give you an introduction and just raise a question. Is it important for me to check it? Is it something worth mention in my company? And I'm challenging you guys to check it after a session. Hopefully, we think it's amazing technology, but we need to convince you guys. My name is Elad. I'm a CTO at Agmatix.
And I'm Kornel Chlebovics. I'm Senior DevOps Engineer at eToro and worked with Elad several years at Agmatix previously.
Okay, so it takes a stand. So we're going to talk about serverless. What is serverless? Different people think of serverless in other aspects. One approach is I want to spend my time and effort writing business logic and not managing my infrastructure. Another approach is to say, I want to run function once and not handling the portability in any systems that I want to deploy this function. This is another approach of looking upon what is serverless challenges. And the third one is, I just want to provide you the code to someone else, and someone else, a vendor, will supply all other challenges. It will provide me all the things that I need. So for many years, containers and serverless was two different things. If you decided to go with containers, it means most of the time you develop microservices, you have your own infrastructures. For at least 5 years, you use the Kubernetes to orchestrate it with Helm and other technologies. And it was very, very good. But as a fact, we all know that functions, Lambda, GCP function, and Azure functions are here to stay. And you see that on the other part of the river, there is the serverless guys. And again, for many, many years, they took other approach. They didn't use Kubernetes, of course. They didn't even use containers. And any paradigm was focusing more, for example, on eventing, on event-driven application, and less on managing microservices and stateless, etc. So for many years, a developer who decided to go the road of containers didn't cross the river to the serverless and otherwise. But this is a problem because we want to leverage from the same technology. How can you do it? I think that the first event or first accomplishment to combine the both, it was when AWS in the reInvent of 2020, they introduced our ability to run and invoke AWS Lambda functions, but to operate it as a Docker container. In the first version of it, it was like 10 gigabytes of Docker container, which is mostly enough for any Docker container. And it's really helped us, even in the perspective of understanding what's happening, it's helped us to understand that these two words can combine together. I can write a Docker container, and I can ship it with a Lambda, and Fargate in Kubernetes and any other technology. This was the first step. But what if I told you that there are still servers in the serverless? It's just someone else's challenge. But are we really dealing in a simplistic way where we're developing our functions and not deploying it to production? And it's not the case. In the serverless ecosystem, it was evolved from just writing the function, and every cloud vendor provided its own native function capability, as I said, in GCP function, Azure function, and of course Lambda. And on top of it, it was evolved into frameworks, such as SAM in AWS and serverless.com. They all facilitate the challenges of managing serverless workloads in production. What it means? It means that I will leverage from infrastructure as code, I will leverage from CI/CD framework, and some more challenges like metrics and monitoring. This is also something that need to be addressed when we're talking about moving into production. You can move forward. But I will tell you one thing. We're doing it, but on the other end of the river, as we said, we have fully blown Kubernetes clusters. We have administrators, we have developers, we're using a lot of other technologies. What I'm going to tell you is the company, as a strategic way, going to tell you, okay, you're running all your workloads in a different technology. Why not combine forces and work together with Kubernetes to run your Lambda function. Is it possible? But the recipe of building a function is much more than just writing one code. So challenges from how I automate the build process in a CI/CD process, how I deploy the application, exposing an endpoint via my ingress, request level load balancing, SSL, scale up and down based on requirements. This is something which is possible in Kubernetes ecosystem, but it's mix and match between different technology. So I think to summarize the problem we see today is that Kubernetes is a very good platform, but even taking a glimpse to the past here, it's like 5 years ago when Kelsey Hightower said, Kubernetes is a platform to build platform. It's where we start. It's not the end game. So what I'm emphasizing here is that it seems like it doesn't make any sense that we will manage Kubernetes in one end. I'm going to say to all organizations and all around the world, this is the way that we're managing now compute and storage. But on the other end, we have different set of technology managing our serverless technology. It doesn't make any sense. So Kornel, is it possible to solve it in Kubernetes?
Okay, so Elad threw us quite a curveball with that last statement. Let's see if we can tackle that with KNative. Okay, so quick show of hands. Who has already heard about KNative before today? Okay, that's great. Let's see if we can change that. So what's KNative? It's an open source project that has been actually accepted into CNCF incubating projects. That's quite a couple of hoops to jump through, as Laurie has explained in her keynote speech. Okay, so if we look at a traditional Kubernetes cluster deployment, we have several layers. It's usually a cloud vendor based managed solution. And we have some kind of networking layer to expose that. And most of the challenges here coming from a developer standpoint, that developer has to concern him or herself with the plumbing of Kubernetes, YAML files, Docker files, different kind of limitations. But at the end of the day, it should just focus on writing code, writing the business logic. So let's mix KNative into the bunch. And this will allow us to give a high-level abstraction, manage the Kubernetes resources with KNative, and give mainly the developer the chance to interact with the cluster in a more natural fashion. And at the end of the day, just concern him or herself with deploying the code. Doesn't matter how it's done, where it's done, it should just work. Okay, and KNative provides us a couple of components to help with that. Serving allows the particular application to be deployed as an HTTP endpoint. Eventing allows event-driven architecture to be deployed within KNative. And the functions allow us that holy grail of function as a service being deployed on top of a Kubernetes cluster and need CLI to tie that all together. And where do we start? So knative.dev allows a really smooth landing into the Knative Wonderland. Provides a local install to get started, really nice tutorial to get familiar with the concepts. Of course, with production deployment, it's advised to use the YAML or the Kubernetes operator to get started. Let's look into the KNative Serving. It will allow to handle some of the challenges that Elad has raised about the traffic splitting, scaling, different deployments, configuration management, and it actually abstracts that concept using a KNative service. This is not to be confused with Kubernetes service. And it manages the configuration, which is a particular encapsulation of the deployment details of the application. Think about environment variables, versions, etc. And with each deployment of the configuration, a new revision will be created. And with each of these revisions, that's actually a kind of snapshot of the application deployment, and the route will route the traffic and piggyback on top of the network layer to route the traffic. At the end of the day, of course, all of these Kubernetes resources will be created, but managed by high-level KNative resources. So when we deploy or update service, new revision will be created. And we can actually use tagging to make more sense about that same revision, and then tie into our deployment strategies, blue-green, and actually use the network layers, which can be service mesh, Istio, Courier, or other options. Split the traffic as part of the services configuration, 100%, 50% as we like. But what happens if we have an increased usage of our application? Bursty traffic. We have Kubernetes, we have a pod autoscaler that can actually handle all that logic by looking at the traffic flow, monitoring different kind of metrics, whether it's concurrency or requests per second or any other custom metric, and it will scale our application up based on those metrics and configurations. It will create the pods as it goes on. But of course, if we don't have any traffic, then we should scale it down. So this can be all configured, of course, per grace period, that it shouldn't happen in a volatile fashion. It will scale it down. And in that case, if we have new requests coming in, it will even buffer the traffic. So that way, any new traffic will be routed to the appropriate pods. Okay, but we want to do even more decoupling and tie our architecture into even something more event-driven, producers, consumers, and all sorts of external systems. KNative provides a solution for that. To help with that, also, we need to speak a common language. So doesn't matter if we have events or event types coming from cron jobs, from Kafka, GitHub. We have another CNCF project called CloudEvents, which provides standardization on top of that, and it can actually provide a common layer. There's an example about CloudEvents. It provides standardization, common metadata attributes, and such. Okay, so a very common pattern on an event-driven architecture is if we want to integrate several systems together, and we want to add some further function into that logic, which we handle within our Kubernetes cluster. So in that way, we have to ingress that external event and egress it outside of the cluster, and provide some kind of processing within the cluster itself. And KNative provides already ready-made adapters to help us with communicating the external systems and emit a cloud event or consume that. Of course, we need to somehow route between different services, because in a production level deployment, we would have several services and functions processing all these events. So a broker can provide us an option to filter based on the cloud event content, and the channel provides a routing option more on a pub-sub kind of model. So if you look at a specific example, if we want to do some kind of custom logic, verify a Jira approval based on pull requests raised by developer in GitHub, and then notify the developer in Slack, then we can try to use KNative for that approach. So in this case, we just connect our service, which is a bit monolithic, approved PR service, and getting the GitHub pull request create event. It does all the filtering, it handles the Slack notification, and it handles the verification. It's a bit clunky, so let's try to use a KNative approach a bit more, and tie-in broker, which allows us for filtering the events based on the cloud events, and use the GitHub source and the Slack sync to rely on the ready-made KNative adapters. And the same service or function can be exposed both ways. We can tie serving and eventing together by exposing it also as an HTTP endpoint, or replying asynchronously using eventing. But at the end of the day, we just want to write a function, right? Let's see how the serverless part comes into play. So if we want to boil this down into 3 easy steps, we can create a function with KNative that will initialize a boilerplate template for all of these languages. We can run that locally as the developer workflow goes. We can build that also locally or remotely using Tecton pipelines. And we don't have to go into the details of Docker files. These will be all provided using build packs and OCI containers. And we can deploy it with func deploy into our Kubernetes cluster. So now it's money time. Let's see the demo.
Okay, so let's see if all this is really can be in 10 minutes. Let's try to do it. So I want to write a function, and I open my shell. And I want to write a function. So func create. Let's see what's possible. Okay, so he asked me to select the language. So let's select Node. Now I need to get my function name. So KSD in Tel Aviv, Node.js is selected, and a func, just an example for a name. I created a function. I can see I have here a new directory. This is a boilerplate of how to write Node.js function. Here we can see that it's just a standard Node.js application. Let's run and install the Node dependency. It's very fast, it's already pre-cached. And let's open IntelliJ, let's open the project. Okay, so when we open the project, and let's move it into presentation mode. As you can see, it's a boilerplate, you get in the README. What you're gonna get here, it's one endpoint for your business logic, 2 endpoints relevant to health monitoring, okay, to understand the metrics. You're going to get a very simple log handler. And of course, you see an example how to run your code, and of course, testing. So let's write our business logic. The main file is index, any Node.js applications, taking time, sorry. Here we can see fully documented, and we have the handler function. In the handler function, I can write my code. And in this case, let's do a very simple case. The case will be I'm going to get an upload, a payload of post request. The post request will be a JSON object, and one of the attributes will be the name. I just want to change it and make it an uppercase of the same name. So very simplistic. I'm going to take the body. I'm going to say that the name equal to body, name to uppercase. This is great. Now, let's check my code as any other developer. What will be the next step? I want to test it locally. So I'm going to go back again to my package.json and run my test. Okay, it's here. But now, and not surprisingly, I see one of the tests failed because I changed the logic. I'm going to see what the assertion told me. When I run deep equal, tiger, it's not in a capital letter tiger. So I need to fix it. Let's close it. Changes to tiger, and rerun the test. Again, package.json, and run the test. So basically, I completed my first step of developing. I changed my code, tested locally, both integration and unit, they have both. And now I want to check it locally in my machine as an application. So let's build it. I do not have here a Docker file, as you can see here, how it's going to work. Using build packs. So I'm going to run func build, and let's use verbose to understand what's happening behind the scene. Okay, so the first question he asked me, okay, where you want to put it? What is your Docker registry? So let's say I want to my Docker registry, local IO, I already registered and signed into this registry. And now, as you can see, it's using buildpack and creating the module itself. It's going to take just a few more seconds. It's analyzing from the last time it built it. And as you can see in a few seconds, it will build a local version of my image, Docker image. Okay, it's saving it locally with this tag, latest, but again, it's not just in my computer. Okay, so we have a new one, and as you see, our S1 updated with the latest layer in the Docker image, but now I want to run it. So we'll just test it locally. Func run. I will skip the build as we already done it, and I will redirect all the logging into a specific file. Let's run it. Okay, it started immediately. I can see in the job it's already running. Let's check my business logic locally. So I run, and I will check it locally. So here I'm posting to my local application with the name Dale. My logic just said, yes, it changed into capital letter. So it's great. So I develop the logic, I update my test, I deploy it locally, and then I test it locally. Very simple. Let's close our server. And now we want to deploy it into our Kubernetes cluster by using KNative. How are we going to do it? With func deploy. In func deploy, we can skip as we already done it, but we still want to see what's happened behind the scenes. So as you can see, he's detecting that the only layer that changed is just the last one, and he's pushing it, only this one, to our Docker registry, and it's deploying to KNative and waiting until the service will be ready. And let's check if this is what's happening. So let's go to my Docker registry, refresh a page, and see how simple it is. I'm just seeing that a new push was updated just a few seconds ago. So this is my latest update. And let's work with the Kubernetes, with the KNative API. So I can run func info. You get more basic details about my function, where it's my endpoints, where it's routes. But I can use the KNative CLI to see the revisions. What it tells us? It's telling us that we have only one revision, and 100% of the traffic go to this revision. Okay? Let's check it. You can see that behind the scenes, if I'm going to run some kind of a stress, let's run this stress, okay? So for 10 seconds, I will run 100 concurrent requests to my endpoint, and will provide some kind of a payload to convert the name for some name to a capital. Let's see what's going to happen. It's going to run, and let's see the response histogram and to understand how well the performance went. Okay, so it's completed. Let's try to see. So it seems like very, very strange. It took us half a minute for most of the requests. Okay, half a second, sorry. Half a minute, it's a batch. And 100 requests in 4 seconds. It doesn't make any sense. So what's the problem? Let's try to run it again. But now, let's run it in the background. Okay, oh, sorry. Now, I will watch my pod. Let's see what's happening. What you see right now is that I tweaked the behavior of the pod autoscaler. I told him that the grace period is 10 seconds. And I didn't spin up any pod preliminary, like with any heating or preloading before, the patterns that we see all in serverless development. So maybe this is why we're seeing the latency here. But let's check the theory, okay? So as you see, there is no jobs. As you see, the last pod is terminated. So it'll be cleanup. Seems like a very usual behavior of functions. Let's change it. Let's go back to our code and just put it here. and go to a func YAML. In func YAML, you can see there is options, and I want to see the schema, okay? Maybe it's not gonna work. Never mind, I have scale. And in the scale, I can decide I want to use minimum of 1. Maybe it's gonna help. What I mean is that in any time, even if there is no active request to this revision of the pod, it still will keep one pod to be serving new requests, okay? But now, let's add more things to my revision, because I want to develop a new revision. I will show you another cool example of functions. You can write func config, and then he asks you, do you want to configure something? Why we need configuration? Because functions still need to communicate with our assets. Asset could be configuration, secrets, config maps. It could be volume, so if you want to connect to a persistent volume claim that you created, and do it in an abstract way in your function. So let's create environment variable. I want to add one. And for the sake of simplicity in this demo, let's just use a static variable. I will call it some param. Okay, I will give it a value 111. And it's created. If you go back, you see it's update my YAML, but this is not enough. This is very, very stupid. So let's go to the index. And let's change the logic. Let's say that now I want to use it. And I will add a suffix that's adding process and what's the name of the param? Param, okay. Okay, let's see if it's working. Okay, and maybe add some kind of something here that you can see the change. So now to make it simple, let's do all the process together. We'll not update the test, just build and deploy it. So we run func deploy, but now, func deploy with the build itself, okay, without it, and we just see the steps. Now you see we're doing both. We're understanding from build packs how to build the Docker image locally, and then we're pushing it into my Docker registry under Docker Hub, under Elad HR, and then I'm pushing the service into production. Let's see. Wait for a few seconds. Okay, we're saving it locally, but now because it's deployed, we're also going to push it to Docker Hub, and we will deploy the service into our KNative cluster. Let's wait for a second. As you see, it takes time a bit. Okay, it's built. We have a new layer. Now we understand which layer we need to push to our Docker registry, and it will be pushing only one, as you can see here. And immediately after, it's going to move to our production cluster. And again, if you go here and update, you have a new revision just now. Let's see how cool it is. So now I added it. Let's see the revision. KN. Now we see two revisions. We have the latest and the oldest. Let's say we want to check it. We said there is a performance issue. Let's check it. So let's run it again. Okay. And now we see what's the behavior. We will get some kind of performance boost here. You're going to see that most of the requests got in a much better time, okay? And why it is? Let's run it again. When you're going to run it, you're going to see that it's terminating all the pods, but it's keeping one. Now let's try to do something else, okay? And as you can see, even after it's completed, we still have one that's always running. Now let's say I want to switch between them. So I will do KN and update the service and tell him, okay, I want to check it. I want to do an A/B testing. 50% move here and 50% to the latest one. Let's do it. Now, you can see that I have 50-50. Let's check it's really routing between them. So I will run right? And I route it to the remote one, and let's see the behavior. So this is a new one. Do you see it's taking more time? Because the policy of this revision was changing, he knows specifically that he needs to spin up another pod for the older revision. So as Kornel explained, when we're tagging a version, it's not just the code, it's a full behavior of our function. And as you can see here, I'll finish in a second. You're just running func delete, and you clean up all the environment. So thank you guys very much for your time. I hope it was good, and we'll see you soon.